The last page of the notes is example 8. Is it hard to see from either of those spots? That's what I was wondering.
Like here, like where Brendan was sitting. It's actually really nice.
Well, then go there.
Here?
Yeah. Yeah, I mean, that's partially why I wanted to keep those outside desks open if I can, because it's like a normal TV where from the sides it's very difficult to see. Is yours spot okay right there? Okay. If you look at section 3, it's very heavily money style problems. So this whole section is applications other than position, velocity, acceleration. And there's nothing wrong with money style problems. But the main reason I wanted to cut out the first whole bunch of examples is they all rely on very specific terminology that you don't need to know. Like revenue, profit, yeah, definitely, yep. Marginal cost, like a ton of very specific terms that you don't have to know on the AP test. So I don't have a problem with money problems. I definitely am okay with the ones where the first equation would stand for some sort of, amount of money, and then the derivative would be like money per hour, something like that. Those are very straightforward, and those I would be good with, but there were none in this section like that. They were all very specific, and I did them last year, and I definitely got the impression that it was very confusing to those who worked on them, and I don't want you to get confused and take away the flow of learning from what you're doing, because like section 1 and section 2 seemed like it went pretty well. And I think section 3 will go that way if I just focus on the regular-ish problems. And then we can get to 4 starting tomorrow. Okay, so let's go with this shark one. Gabby's working on a project that watches the decline in great white sharks in the Atlantic Ocean. Okay, that's just describing what the function's for. So that particular function gives the number of sharks T years since she began working on the project. So it isn't telling you the rate of decline or anything. It is just telling you the number of sharks that were recorded. Find the rate of change for the number of sharks in the ocean after 3 years. So the word rate should automatically be key for you to find derivative. Because if that equation stands for sharks, and we want to know sharks per year, so like the rate of change of sharks, that would be the derivative. So S prime would be our first goal here. How do I do the derivative? This isn't a calculator. No, it's fine. You're using it. I was just curious. Actually, I'm kind of surprised it's not a calculator one though. Yes. So you're going to rewrite the exact same number multiplier will follow to the derivative. When you have e to a power, you just rewrite it times the derivative of the power. So the derivative of negative 0.2t would be negative 0.2. That's what you're using the calculator for? Yeah, that's... say it again? Thank you. Oh yeah, I suppose it just drops off to 0. And then what do I do? Let's, was it Jake? Jake, what do I do from here now that I have the derivative?
You just plug in 3.
Perfect. That'll tell you the rate of change 3 years after it was recorded. So we've got negative 714 e to the negative 0.2 times 3 which you would not be expected to do in your head. I wonder if this whole section is calculator allowed, and that's why there's not a picture on each problem. Whatever that comes out to be is the answer. Now, let's see, Ellen, what would be the label that would go on that? Perfect. So the label is absolutely what I'm going to be focusing on this section. I think the problems won't be that difficult for you. The label is what I want you to focus on. Are we okay with that? Is this one you guys probably could have just done on your own if I just gave it to you? Do you feel? Okay, 'cause I think we've done a pretty good job of discussing what the derivative means. And so I think every time you guys see the word rate or know that it's asking how fast it's changing, you know to do the derivative.
I'm gonna round to the nearest whole number.
Well, that would make sense. Yeah, I'm not too worried about it. But yeah, I mean, like, you can't have a part of a shark. So. Or even if you did have a part of a shark, it still counts as a whole shark. Okay, are we ready for question number 2? Instagram views. Who should we go with? The desk numbers are not correct at all anymore. Ellen? No, Ellen. I got to slow down how I say LN in my head. Okay, call the next person. I know, Ava's not here for you to pick. Oh. So, Jesse? She did it. She called on you. What would you do on this, on number 9 about the Instagram views? So it says that that function stands for the number of views. So instantaneous rate is the just regular derivative. If it asked for the average rate of change, that would be plugging in both points, dividing by their, like algebra 2 slope. So instantaneous rate of change is the derivative. So what would we do for this one to find the answer? I'm okay with us not writing it down because it's awfully similar to the first one and just requires calculations. Okay, perfect. Find the derivative, plug in 5. Do you want to call in the next person? Wow, you guys are so awesome. UK. What would be the label on the answer for number 9? Views per day. Perfect. Nice. So question 10. I wanted to approach this one because it's in table form, so I felt like that might be slightly more difficult and or just it's different. It says the following table of values represent the number of gallons of water in thousands per hour that are flowing into a retention pond T hours after a thunderstorm. UK, is there anybody you want to call on? You guys are killing me. I mean, I could use the roller, but Lucas. I'm trying to think how to phrase this. The original function, what's the label on the original function?
For VT,
Yeah.
gallons of water, flowing into a retention pond T hours after a thunderstorm.
I mean, yes, it would be gallons per hour.
Yeah.
Okay? So what does that already stand for? Yeah. So this is kind of already the derivative. I mean, if we want to think of it as velocity, we can. The V definitely stands for volume, but it's already the derivative of gallons of water. So in A, it says, what is the interpretation of V prime of T? Lucas, is there somebody you want to call on?
Sahi.
What would V prime stand for?
After T hours of the thunderstorm, the rate of gallons increases.
That's kind of already what the table itself is. Because the table is already standing for gallons per hour. So V prime is going to be the derivative of that table. Okay, that's fine. Can anybody help her out? What would be the derivative of gallons per hour? What happens every time we take the derivative?
Oh, gallons per hour.
It'd be gallons per hour, or you could say the rate of change of gallons per hour. Like the way this question's phrased is super generic, so there's lots of different ways you could answer it. I know you guys tend to mold your answers into the way the answer key is sometimes, because you guys read the answer key so much, you feel like that should be the only way that you can answer them. It's not. The answer key is generally only one way of answering things. Interpretation of V prime of T, you could say the rate of change of gallons per hour, or you could absolutely say gallons per hour per hour. That would be the label on this. That would be the label on the answer for this: gallons per hour squared. FYI, those calculators, they designed them to take a 6-foot fall because they think that they would frequently get knocked off of lockers. So when they designed that case, they made them for a 6-foot fall. I wish they did that with phones, like 100%. I've only broken one calculator in my life, and that's because I had it in my backpack when I was in school, and it froze on my way to walking to school. So the screen itself just kind of exploded. But they're ridiculously durable. Definitely not worth $100 and some. But they're durable. Okay, so we've got A answered. Sahi? Yes. I want to call you by your full name all the time. Okay. Sahi, who's going to help us answer B? Carolyn. How do we find the answer to B? We don't have an equation.
You look at the 2.5 and subtract, and then look at the slope equation.
Okay, so which numbers did you say?
T equals 2 and T equals 2.5.
Okay, so you picked 2 and 2.5. That's fine, that works. And that is exactly why it says estimate or estimate, because we don't have an equation to find the exact answer. So Carolyn picked 2 and 2.5 to find the slope between. You could also pick 1.5 and 2. You could also pick 1.5 and 2.5. All three of those slope answers would be a correct estimate. We okay with that? And then we just talked about the label on it, gallons per hour squared or gallons per hour per hour. Now we're not going to actually go through and find C. We are just going to talk about how to figure it out. Who's the last person? Eliza. How would we find when the rainwater flow begins to slow down?
When it keeps like from 0 to 1 going up, and then when it goes from like a higher number to a lower number. So from 2.5 to
Okay? Absolutely, that works. What you were explaining was slope. Yep. So technically, the answer to this is probably going to say find the slope between every set of points on there and find the first one that has a negative slope. That would be slowing down. And that would be the first one is between 2.5 and 3. Okay, good. That's this whole section. Now, when I uploaded the homework in Schoology, I marked on there which problems to do. I can read them off if you want. Uh, 2, 3, 8. 2 and 3 is on page 1. Do them. You're doing all the questions that are not money related. So it's, I mean, like if you're not sure, if it's money related, no. So 2, 3, and then on the third and fourth page, 8, and then 10 through 14. And 14 is the last problem, I believe. So 8, and then 10 through 14. Now, if you want to try some of the money ones, go for it. The first page of notes in the section has all the definitions for the money terms. So if you want to try some, feel free. Like, I'm just not going to assign them.